Start. Hello, welcome back everyone to our channel CodersArcade. This is Saurabh again, and we are back again with our regular live classes in data structures and algorithms in Java. Okay, and I will remind you one thing, this is not language specific. I will tell the logic in general terms, and after that I will write the code in Java. If you have any doubts, you can ask them in the comment section. After that, if you have doubts in any other languages also, it doesn't matter. Okay, so we will be trying to complete the data structures and algorithms course in this live Java sessions. Okay, so yesterday we had covered 3 searching algorithms, if you remember. Okay, linear search, binary search and recursive binary search. Fine. In today's video, I will be introducing you to sorting algorithms. Fine. Okay. If anyone is new to the channel, I request all of you to please like, share and subscribe to our channel, and also hit the bell icon, because that will help you to get notified about the latest updates. Okay. And thank you guys for all your support, and I really appreciate all of you coming and watching the videos and also posting your comments. It really motivates us a lot to bring better content for you. Okay, so with this, let's get started with today's session. As I said, today we will be introducing ourselves to sorting algorithms. Guys, there are lots of sorting algorithms in programming. We will be taking up some very interesting and very important ones which will be helping you in your placement drives. Okay, I will actually tell you the list of all the algorithms that we have, and we will be focusing on understanding some of the most important ones. Okay, some of the algorithms are slow, some are very fast, and based on that we will be taking up some of them so that you can understand each of them in a very good way. And I bet you, when you understand at least around 6 or 7 sorting algorithms, you will be able to figure out all the others on your own. Okay, so let's do one thing. Let's try to understand what is sorting. Okay, sorting algorithms are done. Say suppose I have been given an array, okay, and this array has integers, say 2, 4, 1, 3, 6, 9 for example. Sorting algorithms will need you to sort this array in either increasing order. See, increasing is also known as non-decreasing, or sometimes what we also call this as ascending order. Make sense? So all these are absolutely the same thing: increasing order, non-decreasing order, or ascending order. Make sense? Or the other one is obviously the opposite of this, descending order. So the given array either needs to be sorted in ascending or descending. So in that sense, if I write the ascending order sorting, it will be around 1, 2, 3, 4, 6 and 9. Makes sense? This is the ascending order. It's very simple, right? And the descending order will be the reverse one. It will be 9, 6, 4, 3, 2 and 1. These things you have to do using certain sorting algorithms that have been defined in computer engineering. Okay, so this I will also open the same thing in my mobile so that I can see if you have any comments for me. Right now I don't see anything, so I'll just carry on. So what I was saying is, sorting algorithms in programming, or to be precise computer programming or computer engineering, are the algorithms or techniques which help you to sort arrays in ascending or descending order, and these algorithms vary according to their speed and the way they are implemented. Okay, so we will be learning a few of them, but let me just give you a list of all the sorting algorithms that we actually have. The most simplest algorithm that we have is bubble sort, and then we have selection sort, we have insertion sort, then we have merge sort, then we have quick sort. Okay. These are some of the important ones, and then we also have let me just erase this part, or else let us do one thing, let us not erase this and let us not write it here, we can rather do something like this. I will give the list like this. Okay. We have this 4, we have bubble, selection, insertion, merge, quick, then we have something called shell sort. These are all comparative algorithms or comparison algorithms where we compare the adjacent elements, okay, and then we do some operations. Also, we have some non-comparison algorithms that I had already given you in the beginning, the 7th one and the 8th one. This is count sort, very important guys, very important for your placements, and Radix sort, very, very important. These two are interrelated, so they are actually written together, okay, and remember these two are actually non-comparison algos. Fine. Okay, and after that we have some other algorithms which we need to understand, but before that we have to learn a data structure. There is something called heap sort, okay, but before learning heap sort we have to learn the heap data structure, okay. For that we have to know about trees or binary trees, then only we will be able to learn that, because heap data structure is actually called a complete binary tree. Or in short CBT. You have to understand all these things, do not worry, we will be learning all these things one by one. Right now just let us focus on the topic that we have at hand right now, okay. I am talking about bubble, selection, insertion, merge, quick sort, shell sort, count sort, Radix sort, okay. There are other sorting algorithms also, but these are the most important, okay. So let us start our journey into sorting algorithms by taking one of the simplest one, which is bubble sort, okay. Anybody, any doubt, please let me know in the comment section. I am always ready for listening to your doubts and solving them obviously, okay. And one more thing guys, I just want to say one thing, that along with the sorting algorithms you should also learn the time complexity, the time taken by the algorithms, the big O notation, okay. That also we will do together, do not worry about that. So let us do one thing, let us start with the first one, that is bubble sort, and also we will be writing down the code after learning the logic and the algo, fine. So let us do it. Okay. Currently I do not think there is any doubt, so everything is fine. So let us start with the bubble sort algorithm. What does the bubble sort algorithm say? Let us take an array, simple array I will take, 7, 6, 4 and 3. Okay. The bubble sort algorithm says that if I have a heavier element or larger element, suppose I am talking about ascending order, okay, it can be any order, okay, ascending or descending, it does not matter. The bubble sort algorithm says each iteration the if you are talking about ascending order, the heavier element will be put to the end of the array or to its correct position. Okay. I will repeat again, the bubble sort algorithm says that the heavier element will be placed or shifted to the correct position in the array in every iteration. Because what is a bubble? Let us talk about air bubble. The lighter air bubbles go up, right? Go up, the heavier ones go down. That is the simple concept about this. So, let us try to do this, and you have to do this in rounds or passes or iterations. Remember this, you will be hearing about this many a times. Rounds, passes, iterations. It does not matter how you say about this, but actually they are representing the same thing altogether. Okay. So, let us talk about iteration number 1. Let us take a different color here. 1. Now, you can see that I said let us talk about ascending order, then we can just tweak the code a little bit and it will become automatically descending order. Just the greater than symbol can be shifted to less than symbol, right. And I think, sir, which algo does arrays.sort method follow? I will come to that learning, do not worry about that. See, we have that same sorting algorithm here also in C language also, C++ also. There Anubhav Agnuhatri says, please speak a bit louder. Is it not audible? Guys, please confirm if I am audible or not. I just need a bit of confirmation so that I can verify this. Okay. So, yeah, learning said which sorting algorithm? Actually, this follows the n log n time complexity. So, it should be merge sort. Okay. Because the sort algorithm, yeah, we can just confirm it here. Guys, see, whenever you have any doubts in your mind, then you can do one thing. Say, suppose in sorting algorithm, let me just create a file for the time being. I will just say bubble sort algo. Okay, I am creating the class, and then let us create the main function, and here I am taking an array is equal to say 3, 2, 1, 4, 5, and I will just say arrays dot sort, let us take ARR, okay, and then I will just say S out our array, or rather than doing like this, I will just call arrays. Guys, can anyone tell me what is a good way to print this array in one single line? I can say there is a function or method called toString, and here you can see it takes an integer array. So, I am passing our ARR after that. Let us now see what we are getting. See 1, 2, 3, 4, 5, it's sorted, right. So, learning, you were asking about this. See, I have showed you this, and here you can see this. Okay, if you hover over this, you can see here. Learning, can you see this? I hope you can see this, or you can just do one thing. Okay, if you are using IntelliJ, just hover over this, you will see something written here. Let me do one thing. Let me copy this for you, because I don't think this color is actually visible for you. I will copy this for you, and I will do one thing. I will go to my notes section, and there I will type it for you. Okay, I will copy whatever I have seen there. Just see this. You can see here, right? This algorithm offers O of n log n. N log n is for merge sort algorithm, or you can also say quick sort algorithm. So, it is n log n. So, for that you have to understand merge sort. Okay. So, I hope now you have understood that, right. Whenever you have anything like this, any method you are using, just hover over it, it will give you this idea what is actually going on in that. Okay. Make sense? Now, I hope your doubt is clear. We will not be using this built-in method, okay, do not worry, we will be using our own sorting algorithms. We are learning them, we will be using them, do not worry. Yeah, very good. Anubhav says two string method, very good. Yeah. Fine. So, let us get back to our logic that we are using. Yeah, I was talking about the first iteration. Here what happens, just see here, the heavier element is actually compared with the adjacent element, and if it is bigger, it is swapped, they are interchanged. Okay, this becomes 6, 7, 4 and 3. So, this is the new array now, and this does not finish, it keeps on doing it, repetitive swapping. Now, this again 7 and 4 will be compared, obviously this becomes 6, 4, 7 and 3. See, again this thing will be done. See here, this will be done for 7 and 3 again. Now, this becomes 6, 4, 3 and 7. Did you see this? Hope you understood this. Now, this is the first iteration where the largest element goes to the end of the array. Make sense? Now, this whole array will be taken up here for the round number 2. Is that clear? Now, see this. I will write 6, 4, 3, 7 and we will continue with the same kind of operation. So, you can see one thing, guys. This array part is sorted and this array part is unsorted. Make sense? Now, see, again the same thing will happen. So, 6 and 4 will be interchanged because 6 is larger, right? We are doing ascending order. So, this becomes 4, then 6, then 3, then 7. Fine. And then now what happens? Again this 2 will be done, right? So, this becomes 4, 3, 6 and 7. Got it? Now, you can see one thing, very important thing. See, 7 was already sorted. Now, I got 2 numbers sorted. This is the sorted part, this is the unsorted part. You can see every time, every iteration, the largest element is reaching its correct position. That is why it is called bubble sort. There is repetitive swapping going on, so that the largest element reaches its correct position. The largest element reaches its correct position. Make sense? Now, this thing will go down for the next iteration. What is that iteration? This is 1, 2, then this will be 3, third iteration, right? Make sense? Now, just see. I will take this array. This is 4, 3, 6 and 7. Let us do it now. See, 4 is greater. What happens? You will do a swap. So, this becomes 3, 4, 6, 7. And just observe the largest element. This was the sorted part, this was the unsorted part. Now, see, the largest element has reached its correct position and now the whole array is sorted. There is no need of any more swaps. So, how many elements did we have? We had 4 elements, correct? 4 elements. How many iterations did we need? 1, 2, 3. Got it? So, for n number of elements, we will be needing n minus 1 passes or iterations. Is that clear? Did you understand this? For n minus 1, for n elements, we need n minus 1 passes or iterations. Please make sure you understand this. Is this clear? Now, guys, I want to tell you one more thing. So, let me write it down here in a different color. So, for n elements, we will need n minus 1 iterations. Is that clear? I hope it is absolutely clear now. Now, every time you can see that I need less elements every time. Initial stage, I needed the whole array. After that, I only need 3 elements. After that, I only need 2 elements because I am getting the sorted part automatically. After that, I will be needing 2 elements, 1 element, it will keep on going like this. So, now you just see that. Let me write down the logic so that you can understand. See here, first it was n elements, then it became n minus 1 elements, then it became n minus 2 elements, then it became n minus 3 elements. Okay, we have got a relation. Suppose I take a variable I is equal to 0, 1, 2, 3 dot dot dot. I can just write this formula for the number of iterations I am talking. Okay, how many? For n values I needed n minus 1 iterations. Okay, so how will I write that? Tell me. For I is equal to 0, how do I write this? Tell me. You have to tell me, how do I write this? Yes, what should be the logic behind writing that? I less than, how do I write it? See, our index actually goes from 0 to n minus 1, right? The indexes are till here, but for these many elements I do not need to go till n minus 1, right? So, how do I write it? Yeah, has anyone written anything? No, there are no comments, it is okay, fine. So, I am saying int I equal to 0, I less than n minus 1 if I write, this is absolutely fine. This is for n minus 1 iterations, make sense? Is it clear? And then I plus plus. Hope you have understood why I have written n minus 1, because it is starting from 0. That is why it should not go till here. I need to go till n minus 2. Got it? Clear? And for this one, what I am saying, every time I am needing one value less, right? Every time I am needing, first time I need all the values, second time I need only till here, then till here, then till here. This is what? N minus 1, n minus 2, n minus 3. So, I can write for, to compare this value, this is the I value, say this is the j value, j is what? J equal to I plus 1, right? The next value, got it? So, how do you write it? Tell me. I can say int, let us say j equal to 0. This is for the number of iterations. Now, I need to compare the elements. Let us say I need to compare this with this. Let us take one variable only, j, not to confuse each other. Let us do one thing, j equal to 0. How do I compare with the next element? I will write that. J less than, just try to understand this. If I have anything here, can I compare with the next element? I can't. Okay. So, I will write j less than n minus 1 I can write, or because every time one element is decreasing, I can take this I variable. You can see initially 0, so it will go till the last one. After that, just try to understand guys, you might be confused. So, what I am saying is something like this. If I write, sorry, array length minus 1 order, yeah, absolutely fine, it is correct. So, what I am saying is j less than n minus 1, I can write like this. See, if I write j less than n minus I minus 1, try to understand guys what I am saying. If I write like this, what does it become? Sorry, initially it will be n minus 1 because I is 0, after that it will be n minus 2, after that it will be n minus 3 and so on, because every time I write this. Or else if you write like this also, that is also fine, otherwise you can optimize it by writing like this also. Got it? And you just have to swap the values if it is greater. So, you know the swapping thing, temp equal to a equal to b equal to temp, that you can do, right? Let us write down the code and understand that. Fine. Sir, can we apply binary search on string type? String type, you can do it, but it has to be converted to ASCII code actually. Based on that, it will be doing it. Okay, directly on strings, it will be difficult to apply binary search. You have to convert that to characters and you have to do it like that. Just try doing that, and if you find any difficulty, let me know in the comments. Okay, fine. So, let us do one thing, let us write down the code and try to understand this, what I am saying. Okay. So, bubble sort, yes. So, rather than writing this, what I will do is, let the array be this one only, and anything we can take, okay, it does not matter. So, let me create the bubble sort function. static void bubble sort, and let me just check if the, just let me know guys if the font size is okay, or else I will try to increase it. Okay, hopefully this font size is okay, and int, it will take the array. That's all right, I need the array, there is no key, you just need to sort them. Okay, so let's start. For int I is equal to 0, I less than what, n minus 1, I plus plus. Yes, what is this n? I don't have that n, right? So, I will write arr dot length minus 1. Make sense? And just remember this for your understanding, I am writing this is for the number of iterations, or rather than writing here, let me write it here. This first for loop is actually for the number of iterations. Okay. Now, let us go to the comparison part. So, what I said, I will start with j is equal to 0 and say j less than n minus 1. Okay. Why this? Why it is? I can also say arr dot length minus 1. Okay. And j plus plus. I need to compare the current element with the next element, the adjacent element. So, I will just say if our arr of j is greater than arr of j plus 1, what do you do? If it is not in the correct position, right, what do you do? We swap them, right? How do you swap? I will just say int temp equal to a, or my bad, I should not write a, I should write arr of j. Okay. Arr of j is equal to arr of j plus 1, got it, and arr of j plus 1 is equal to temp, got it. That is all you had to do guys. That is in simple terms your bubble sort code. Okay. Let us do one thing, let us see if this is working or not. So, what I will do, I will not call this, I will just call bubble sort here, and let us see if this is really working or not. Let us run this and see. See 1, 2, 3, 4, 5, it is actually working like this, right. See, I will again repeat myself, as I said, number of iterations is n minus 1. If it is going from 1, you can write less than n, because it is going from 0. So, I am writing less than length minus 1 or n minus 1. Okay. Fine guys, you can take this arr dot length and store it into a variable and do it, it does not matter. Okay. You can write like this, it is totally your choice. What I am speaking about is something like this. Okay. Int n is equal to this value, whatever I am saying, cut this from here and paste it here. If you are getting confused about this, then you can write here as n minus 1, and here also you can just convert this into a n minus 1 value. Okay guys, one moment, just one moment. Okay, yeah, I am back, sorry for the delay. So, what I was saying is, you store it into a variable and do it. Now, just see, this is for the comparisons. Okay, this is for the comparisons. Make sense? This is for the comparisons, and then we are doing the swap. Fine, got it. And now, as I said, this code is working absolutely fine, there is no errors in this, and you saw the output, right. You actually saw the output, and we had got the output like this. I am just converting it into a string and printing it. Guys, if you do not want to print like this, you can take a simple for loop and do it, but I am doing it to show you some built-in functions of arrays. This is a very important class guys. This is a very important class which has lots of built-in methods for arrays. It is there in the package java.util, please remember that. Okay, fine. So, any doubts? No problem. I think everyone is understanding. So, what I will do is I will talk about the optimization that you can do here. See here, every time I am needing a element less, right? So, what did I say? I will change it to n minus I minus 1. I said that, right? Let us try to do that here. What I am saying, j less than n minus I minus 1. We should be getting the same output. Let us see. See guys, absolutely same output. Okay, just for your reference or your validation, let us take some other numbers also. Say I will take 0, say I will take 7, say I will take 6, say I will take 9. Let us run this. It should work absolutely fine. It does not matter. See 0, 1, 2, 3, 4, 5, 6, 7, 9. Got it? So, this is the optimal code for binary bubble sort, and it is working absolutely fine, and I hope you have understood this. If you have any doubts, please feel free to comment in the comment section. As I told you, right, this is optimized because initially it is 0, we are needing every time 1 less element. So, first we had the whole n, after that n minus 1, n minus 2, it keeps on shrinking, right, the size of the array shrinks because each time we are getting a sorted array. One part of the array is getting sorted automatically. You can see here. See, we get this part sorted, then this part was getting sorted. See, automatically. It keeps on reducing. That is why it is working like this. I hope you have understood this. Okay. Now, let us talk about what? Important thing. Time complexity. Let us talk about the time complexity. Okay. Bubble sort is not a fast algorithm, and it is recommended for only smaller size arrays, not for bigger size arrays. Okay. So, we have one for loop which is going for the iterations. Let me wait for the internet connection to be stable. Yeah, it is stable. Okay. And we have one more for loop for the comparisons. Got it? Say suppose this for loop is going, for example, 1 to n, whatever value n times it is occurring, and this is also going 1 to n. So, in that case, the complete time complexity for the first one is actually O of n, this for loop. Similarly, this for loop is also big O of n. So, ultimately the total time complexity is actually the product of these two, that is big O of n square, n cross n, that is n square. Okay. That is the time complexity of bubble sort. It is a slow algorithm and it is not recommended for larger size arrays because it takes a lot of time. Okay. Hope you have understood this. Fine. Any doubts about bubble sort, let me know in the comment section. Okay. Fine. Got it. I hope you have understood this. Now, let us move on to the next sorting algorithm, which is what? Selection sort. Fine. And if you guys need the codes that I am writing in the live sessions, make sure you post your comments about the codes if you really need them, because I really need to know that you need the codes. Okay. Then I will be sharing them using a GitHub repository, and you all can access all the codes. For all the live sessions that we will have, I will share the repository and you will have all the codes together for you. Okay. We can do that, no problem at all. Just ping me in the comment section if you really need the codes. Fine. Thank you. So, let us go back to the next one. This is also a very beautiful algorithm, that is, I do not know, many people find it difficult. Okay. I have got this question from lots of students, whenever I am training them in the colleges or maybe in my office also, whenever students come for that, I have seen this question a lot of times. The question is, how do you differentiate between one sorting algorithm to the other? Guys, you have to understand the name, and after that remember what actually it does. What is it doing actually? You have to remember that. Okay. So, just remember, when I said bubble sort, I said swap. Selection sort also does something like that. You have to remember that, swap. Selection sort also we do swapping, but we have to understand when do you do the swapping. Okay. So, that you need to understand. So, let us do one thing and try to understand. Let us take an array. I will take an example like say 60. Okay. Do you have any more comments? No, it's absolutely fine. So, guys, let us continue with this. I will say 64, 25, then 12, then 22 and 11. Okay. This is my array that I have with me. Fine. So, what does selection sort algorithm say? Selection sort algorithm says that at every iteration we can have ascending order or descending order, right? Suppose we are talking about ascending order only. So, at every iteration, at each correct position, the least value will be stored. The least value will be stored always. Please remember that. Okay. If you are talking about ascending order, obviously the least value will be stored. But if you are talking about descending order, the greatest value will be stored. Please remember that. Okay. So, in the first pass or the first iteration, you can see the least value will be stored at this index, the 0th index. Okay. How do you do that? I will consider that this is actually, suppose this is a variable I. Okay. And what I am doing is, I am considering that this is actually the min index. I will tell you why I need this. I will tell you why I need this. I am considering that the min index in the beginning is I only. That means the least element of the array at that current index is there only. After that, what I do? I start traversing from the next element. So, I will check 25. Okay, let me draw this line, and 25, 12, 22, 11. Which is the least element in the array? 11. So, 11 will be swapped. 11 will be swapped like this. So, this two will exchange positions. Got it? So, the array will be like this. 11 comes here, then 25 will be as it is here, 12 will be here, then 22 will be here, and this 64 will come here. Make sense? Okay. So, see here what happened. 11 came here and 64 came here. Got it? Now, I value was 0, I gets incremented and I comes here. Clear? Now, again the same steps will be repeated at this particular index, but how do you do it? Okay. Min index was I, right? I will tell you that also. See, I am starting j with here. Okay. J keeps on going like this, j keeps on going like this, j keeps on going like this. You try to compare 64 with 25, it is less, right? It is less, but keep on going, you found the least element here. So, the min index from I becomes j. Okay, min index from I becomes j, and then we interchange the ith element at the jth element. That is what happened. Okay, same thing. I is here. So, you see this part is sorted. Now, 25 will be compared, j will come here. Which is the least element? See, traverse the array, see 12 is the least element, right. So, now 25 and 12 will be exchanged or swapped. How it happens? So, I will write down this again, 11 is here. So, 25 and 12, see I and j will be swapped. If the min index changes, they will be swapped, otherwise there will be no swap at all. If it is at the correct position, we do not need to swap. I just need to check if the min index changes from I to j, because what I mean to say is I am considering this as the least element of this part of the array, but if it is not, then I need to swap them. So, I will just swap with the jth index, got it, the other part of the array. So, here you can see 12 comes here, 25 comes here, and then 22 will be as it is, 64 will be as it is. Make sense? So, this way the cycle keeps on going like this. Now, see what happens. Let me keep this intact, okay, and let us try to write down again something like this. I will take a different color now. So, this part is now sorted, 11 and 12 were sorted. So, sorry, my bad, this is 11 and this is 12, these two are sorted. Now, I need to do the same thing for this one. Now, see, I was here, I moves here. So, now see 25, 22, 24, which is the least element obviously. So, this 2 gets swapped now, 22 comes here, 25 comes here and 64 comes here, got it. And after that you can see this is at the correct position only, after that there are no more swaps, got it. Is that clear? That is how it is happening, every time it is happening. So, what do you understand actually? If I take any other array also to explain this again, you will understand one thing, that if I have say 4, 8, 1, 6, 5, for example, I am taking another one so that we can understand this. See, what I said is this index, this current index, I need the least value. I need the least value. What is the least value in the whole array? 1, but this will be swapped with this one, got it, and 8 remains here, 6 remains here, 5 remains here. This is how it works. Now, if this part is sorted, I will not touch this, 1 will be as it is like this. Now, we do this operation from this part. What is the least of this part of the array? Let me take a different color. Least of this part of the array, what is that? This is 4. So, 4 and 8 will be getting swapped here, got it. Then 6 and 5 will be as it is. Now, let us take a different color, same thing again, 1 and 4 are sorted. Now, we have to do this for this position, okay, same thing. You can see 5 is the smallest, 5 gets swapped with 8, got it, and 6 will be as it is. Now, this part of the array is sorted, you can see this part is sorted. I take a different color. So, this is the sorted part, and then 6 and 8 are already sorted. So, there will be no more swaps, it is absolutely fine, got it. That is how it is working. So, I will repeat one thing again, for each position it should have the minimum element, okay. If it already has the minimum element, do not swap. Otherwise, if you find any other minimum element, swap between them. Just do a swap between them at every position. That is how simple it is. Okay, let us write down the code so that you can understand this. Got it? After that, we will talk about the time complexity also. Do not have to worry about that. This time this is selection sort, right? Selection sort, I will go. Right. So, public static void selection sort. What does it take? It takes the array, that is all, nothing else, because we have this feature in Java, arr.length, got it. So, let me do one thing, I will store this n as arr.length, let me do it, and guys, just let me know if the font size is okay, because if you are not able to view this font, then yeah, I can make it a little bit bigger. Just give me a heads on, guys. Just tell me if the font size is okay or not. Fine. So I have stored the array length. Now let's do the traversal. Okay, as I said, for I equal to 0, I less than n minus 1, and here I also did not tell one thing. In this algorithm also, what happens? Every time one element is getting less, right? For n elements, it will take n minus 1 iterations. Okay, if I am starting from 0, it will go till n minus 2. We do not have to go till n minus 1. So 0 to, I will say less than n minus 1. This is the iteration variable. Okay, got it? So let's write down this. I equal to 0, I less than n minus 1, I plus plus. Okay, as I said, every iteration I consider this index to be the minimum index, and then I will traverse and find if in the other part of the array I have any minimum value, I will switch the index from I to j. Okay, got it? So I will write like this: int min index is equal to I. The current place has the least value, I will say. After that, let us check. I will not check with the current, I will check the current with the next. Okay. So int j is equal to I plus 1, okay, the next element, and j less than n. I have to go till the last element, okay, till the last element I have to go. From here till the last element I have to go. 4, I will compare with all the elements and I will find the min index or the least element, okay, j plus plus. If any element in the array is less than, that means if any element in this part of the array where my j value is moving, j is less than I, this particular element, I will change the min index first, okay, less than ARR of what? The ith value, or I will say min index, because min index is I now, right? I will write like this. Then what will I do? I will change the min index is equal to j. Got it? My min index was this one, I found that, okay, here keep on going, I found that there is one more element which is even smaller. So my min index will become j now, this value. Got it? After that I will do the swap. So after this traversal, after this for loop, I got the min index at that. So I will just say, I will check, okay, I will do a check. Do I really need to swap, or is this the correct position only? Suppose 1 is here only, I do not need to swap, right? So I will check, has my min index changed? So how do I check that? If my min index is not is equal to I, that means, oh, it has changed. And my min index was the first element, it has changed to j. So I need to swap them. So how do I swap? I will say temp equal to ARR of min index, that particular number, this one, and ARR of min index is equal to ARR of what? I. Swap this two, ARR of I, ARR of min index, like this, and the last element is ARR of I is equal to, it will become the temp variable. Okay, I am only doing this if needed, so I am writing this condition. That is all. This is simple selection sort, guys. Got it? Now we just have to call this method to verify whether it is working or not. So let us do one thing. This is our function, and here let me create the main method, and I will create the array. Let us take the same examples 4, 8, 1, 6, 5, whatever you want you can take guys, it does not matter. 4, 8, 1, 6, 5, okay. And then I will call the selection sort function, pass my array, and then I will just say s out arrays dot toString and pass my array. Fine. Let us see if this is working or not. Run this and check. 1, 4, 5, 6, 8. That is what we are looking for, right? 1, 4, 5, 6, 8. It is sorted. Got it? This is how simple even selection sort is. Hope you have understood this. And see, if you do not write this also guys, it will work. What I am saying is, if you remove this line, let me comment this line, okay. Let me comment this line. Let me comment this line and run this. I am not doing the check. Let me run this. It will give you the same output. It does not matter. See, it will work. But I am doing this because sometimes we are not needing to check that. Suppose 1 was at this current position only. Say I have an array like this 1, 4, 3, 2, 6. Do I need to swap the first element? The minimum element is at the beginning only. Why do I need to check this? I do not need to do the swap. So, if this does not change, I will not do it. I will start from the second element. This will be skipped. Got it? That is why the if condition is important. Okay. That is why I had written this line like this, so that I can do this check. Hope you understood this. Okay, guys. Any doubts about this, please let me know in the comment section. I will be very happy to clarify all those doubts. Got it? So, we have understood two sorting algorithms, bubble sort and selection sort. Now, let us move on to the time complexity of selection sort. It is absolutely same. Can you tell me why? The time complexity of selection sort is also big O of n square, because we have one for loop for the iterations and one for loop for the swap operations or the comparisons and swapping, right. So, you can say this one goes for big O of n and the other one also goes for big O of n. So, ultimately, because it is a nested, remember whenever you have nested for loops, the time complexity, suppose I have for inside, this is say O of n, O of n, O of n. What will be the time complexity? It will be n into n into n. So, big O of n to the power 3. This is very slow. So, bubble and selection sorts are slow algorithms and it is recommended to use them for smaller size arrays. Okay? Got it? I hope you have understood this, and also you have executed this code along with me, and if anyone is practicing this, make sure you are writing this again. Okay? So, bubble sort, swapping the adjacent elements till the heavier element goes to the end or the lighter elements come to the front. You can say it anywhere around. Selection sort, at the current position, I need to put the lighter element or I need to place the correct element at that particular position. Make sense? The correct element at that particular position, that is selection sort. Selection sort also we are doing swapping only. Okay, got it? Now, I had given you a list of algorithms. Out of that, I told you we have already covered how many? 2, bubble and selection. Now, let us go to one more, which is very important. I bet you this will be not taught to you in your college or your syllabus. Count sort. It is a very interesting algorithm. Got it? So, let us learn this count sort algorithm and try to understand how it works, because it is a very unique one. Okay? And do not worry, we will be covering merge sort also. It will take a lot of time to understand and execute the code. So, it will take a lot of time. Today, I want to at least tell you the algo for count sort algorithm. Okay? So, let us write down or try to understand that. Okay? Anybody, any doubt, please feel free to comment in the comment section. Okay? And guys, again, new to the channel, please subscribe, hit the bell icon and also share it with your friends and family, so that we get more subscribers, you get good live sessions. Okay, please stay tuned. And also I will give the Telegram channel link in the description this time, so that also you join the Telegram channel for latest updates on coding questions, notes, PDFs and placement drives also. Okay, so let's go to count sort algorithm now. In non-comparison algos, this is the first one, which is count sort algorithm. Okay. So, let me tell you the features of this one. This one works for single digit whole numbers. Single digit whole numbers, that means 0 to 9. Okay. And it is also a non-comparison algo. Let us talk about the steps, and before that let me create a array of single digit whole numbers. So, let me write down the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and let us take random numbers. 2, let us take a different color. 2, 1, 4, 3, 2, 3, 1, 4, 2, and let us make it a little bit interesting by taking a larger number also, say 6. Okay, and let us do some tweaks by writing like this. Let us write 6 here and write 2 here. Okay. Otherwise, it will feel like it is already sorted. Fine. We took this array and let us try to understand what happens here. The first step of count sort algorithm is find the max value. Okay. Find the max value. What is the max value in the array? What is the max value in the array? 6. Okay. Based on that, we got 6 as the max value. Okay. Based on that, step 2, create a count array. The count array indexes will be from 0 to 6 indexes. Okay. Let us create a count array now. The count array indexes. So, I am writing, this is my input array, okay, and let us take the count array now. Count array indexes will be 0 to 6. So, let me write down like this. Zero, 1, 2, 3, 4, 5, 6. Okay, 0, 1, 2, 3, 4, 5, 6. Make sense? Now, let us count how many zeros. There are no zeros. So, I will write 0 here. If I had zeros, I will put that count here. Okay. After that, how many ones? If you see, there are 2 ones. Correct? 1, 1, 2 ones. How many twos? 1, 2, 3. 3 twos. How many threes? 1, 2. So, 2 threes. How many fours? I can see that there is only 1 4, right? Okay. So, 1. How many fives? There are no fives. So, I will write 0. And then how many sixes? There is only 1 6. So, 1. Got it? I have just taken the counts. That is all. Fine. Now, let us take examples to understand the next step. The next step is actually, before understanding the next step, we have to do one thing very important. Okay. I will say something which you have to understand. Say, I will tell my colleague's name. Say, I have Tanmay, one of my colleagues, or my friends. Tanmay is one of my friend. I have Chandan, and then say I have Milan, and I am giving numbers. Tanmay has 1, Chandan has 2, Milan has 3. Got it? Now, suppose I am writing Ujjwal. I am writing Ujjwal. Can I write 9 here? After 1, 2, 3, serially I am going, right? I cannot write 9 here. I have to write 4 here. Got it? So, the current number is dependent on the previous number. Similarly, the current position is dependent on the previous position. When this kind of a scenario arises, you have to calculate something called, let me write it down here, the step 3, you have to calculate cumulative count, just like you had done in frequency distribution tables while learning about graphs or histograms in what to say, class 12 or class 11, when you were learning histograms, bar charts and bar diagrams. Okay. So, when the current value is dependent on previous value, you have to calculate the cumulative count. Okay. How do you do it? See, but do you think for Tanmay, does he bother about who is before him? Nobody is before him, right? So, Tanmay just comes and sits here. There is nobody before him. What do I mean? This first number will directly come and sit. Let me show you how. Okay, I will do one thing. I will just drag it a little bit up. Fine. Now, let me draw this. Zero, 1, 2, 3, 4, 5, 6. Okay, just what I said. Say this is Tanmay. There is nobody before him. Tanmay will directly come and sit here. So, what will I write? Let me take a different color here. Say yellow or say orange. Okay. Now, see, this 0 comes and sits here directly. Got it? After that, cumulative count 0 plus 2, how much? 2. 2 plus 3, how much? 5. 5 plus 2, how much? 7. 7 plus 1, how much? 8. 8 plus 0, how much? 8. 8 plus 1, how much? 9. The last number that you got should be equal to the length of the input array. It should be equal to the length of the input array. Just check and verify. 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 index means 9 elements. If you are not getting this, there is something wrong with your conditions that you have applied or the calculation that you have done. Got it? That is what is called cumulative count. Just remember, current is equal to current plus previous. For the first one, there is no previous, so I just put it here. But for the other ones, there is some previous value. So, I am adding current equal to current plus previous. Make sense? Got it? Now, next step, the step number 4. Create the output array. Okay, let's create the output array now. I will write down here. Yes. Let me reduce the size a bit. Okay, fine. Okay. And let's do one thing. Zero, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, write down the indexes 2, 3, 4, 5, 6, 7 and 8. Guys, please focus now. It is a little bit tricky, but not that much tricky. Please try to understand. Fine. We added them from left to right. We calculated the cumulative frequency from left to right. While storing, we will store from right to left. Store right to left. That means end of the array. Okay, let's do it. What is the first number? What is the first number? The first number is 2. This one. What is the total count or the cumulative count of 2 here? 5. But we had added with the previous index. So, just subtract 1. 5 minus 1 becomes 4. Try to understand. At 4th index, here I will store this number 2 here. Got it? Same. 6. What is the total count? 6 is 9. 9 we added to it here, right? So, 9 minus 1 becomes 8. At the 8th index in the output array, we will store this number 6. 6. Got it? This is how it will work. And see, 6 is the largest number. The largest number should be at the end of the array only. Got it? That is how this algo is working. Now, let us take the next one. 1. What is the total count? You can see 1, 2, 2 minus 1, 1. At the first index, I will write 1. Okay, keep on going. 3, count of 3, see 7. 7 minus 1 becomes 6. At 6th index, I will write 3. Okay, after that, I have 2. See the count of 2, okay. Count of 2 was 4 now. 4 minus 1 becomes 3. At 3rd index, what will I store? 2. Next number is 3 again. What is the count? 6. 6 minus 1 becomes 5. 5th index, I will store 3 again. Understanding how it is working? Got it? Now 4. What is the count of 4? See here 8. 8 minus 1 becomes 7. 7th index, sorry, I have written it wrong. This is 7. 7th index, I will store 4. This particular number. That is why I am circling them off. Then 1. What is the count of 1? See 1. 1 minus 1 becomes 0. At 0th index, I will store 1. Last one, 2. What is the count? You can see here, count was 3, right? So, if I go and write 3 minus 1 becomes 2. At 2nd index, what will you store? This last number, 2. Is it sorted? Look at the array and tell me, is it sorted or not? 1, 1, 2, 2, 2, 3, 3, 4, 6. This is the sorted array. Got it? Just comment if you have learned something new here or not. I hope you have understood a very interesting algo today. What is the time complexity now? The time complexity is big O of n plus the max value, whatever the max value you have. It is linear time complexity. So, it is faster than bubble sort and selection sort also. Linear time complexity. Okay? It is not n into n or something like that. So, this is how the count sort algorithm works. Okay? Understood this? So, I hope you have learned something very good, and I think I have a comment here. Love your teaching, sir. Can you also solve most asked interview questions related to the topic? That would be helpful. Definitely, I'll be doing that. I was actually targeting something like understanding the concepts, knowing the logic, writing the pseudo code, then writing the code. And don't worry, at the end also, we'll be doing some important interview questions that has been asked in many MNCs and other coding round questions. Okay, don't worry, I'll be doing that. Okay. Yeah, we'll be doing everything like that. Don't worry about that. Try to focus and stay with me till the end of our live sessions. I bet you will be learning a lot of things together. Okay, so this much for this video, guys. Okay, and at the same time, I will say that thank you everyone who is watching all our videos. If anyone is new to the channel, please subscribe to the channel, guys. It is of immense motivation to us. And tomorrow I will be coming up with the code for count sort algorithm, and we will be learning one or two more sorting algorithms also. Don't worry about that. Okay, fine. And tomorrow I will also try to solve one question for you as suggested by someone. Yeah, he says thank you, welcome, and your name is my username. So how should I call you? Anyways, thank you for that. Thank you for your comment. Okay. So, I hope you understood a very interesting algo today. Tomorrow I will be showing you some more sorting algorithms and also will be writing code. Today actually I am out of time, and so I will be winding up today. Thank you for watching, guys. Please subscribe. Okay, that is what I need from all of you. Okay, so till tomorrow's video, this is Saurabh signing off. Bye bye and happy learning. Please stay tuned.